After a while of sharing sliders for the website, I found it a bit boring, so I came up with a new idea using knowledge of three-dimensional geometry. I decided to simulate it using CSS and create a new design. Code with Artemis designed an image slider for the website in 3D space to create an endless loop, and of course, I only used CSS for this design. Combined with images and content layout, it creates an extremely impressive and trendy design. After this video, everyone will understand and easily apply the rules of three-dimensional space to their designs. Additionally, in previous videos, I encountered many questions about how to design text that overlaps an image. At the end of the video, I will also guide people to create it. If you find it interesting, please don't forget to like and subscribe to the channel to watch more interesting videos every day. Thank you very much, and now, let's get started. Here, I have prepared an HTML and CSS file. On the right is our website. First, I will create a banner class element. Inside, there will be two elements, slider and content. The slider will include many items, and each item will have its own image. I will create an item first. Now, let's get to CSS. First, I need to create dimensions for the banner frame. With 100% height, 100% of the height of the screen, center the content, and use overflow hidden to help elements that fall out of the frame to be cut off. Finally, position the element with the position relative property. Next is the slider class located inside the banner. Use position absolute to easily move the position according to the parent element with a width of 200 pixels, height of 250 pixels, and 10% from the top margin of the banner to put the element in the middle. Then it will be 50% from the left margin minus half of its width value. Next is the list of items. Each item also uses the position absolute attribute to fix the position. It will be 0 pixels away from the 4 directions, top, left, right, and bottom. This will give it the same size and position as the class slider. As for the images inside, it simply has a width and height equal to the size of the item. To avoid distortion, add object fit :cover. So, we have completed the first declaration steps. Now, let's focus together, because knowledge about three-dimensional space will be relatively complicated. To have the ability to make changes in three-dimensional space, first, in the slider frame, we must declare transform style, preserve 3D. Along with that, transform perspective has a value of 1000 pixels. Let's look at the following model for easier visualization. With two-dimensional space, we can move elements in two directions, X and Y. But in three-dimensional space, we have an additional direction, which is the Z direction. The distance from the element to the bottom of the screen is now the 1000 pixels we declared earlier. Okay, our next task is to arrange the positions of the items around the slider to form a circle. For example, the circle I want will have a radius of 550 pixels, measured in the Z dimension. Now, we just need to move the items in the Z direction of 550 pixels, and that item will immediately be located right on the circle. So, in the code, each item uses transform to move the position. I want to move it in the Z direction by 550 pixels. The first job is done. Similarly, now I will return to CSS to create other items. For each item, I will insert a different image. Once added, everyone can see the items are now on top of each other. Our task now is to divide them into different positions appropriately. Look how I simulate. After getting the first item, I create a second item and move it in the same Z direction as the first item. Then I'll rotate it along the Y-axis by 20 degrees. Then this will be its location. Likewise, with other items, when we rotate along the Y-axis with increasing values, these items will surround the original circle. The problem raised here is to create a standard formula to calculate the rotation angle of each item so that the items are always arranged evenly. For example, here I have a circle containing 4 items inside. The starting point of a circle is always 0 degrees, and the ending point is 360 degrees. So, the distance of each item to ensure it lies evenly on the circle is 360 degrees divided by the number of items. Here we have 4 items, which is 360 divided by 4, so the distance of each item is 90 degrees. Everyone can easily see that the distance from 0 to 90 is 90 degrees, and the distance from 90 degrees to 180 degrees is also 90 degrees. So, the rotate Y value of the item at a specific position will be calculated as follows. It will be equal to its position minus 1, then multiply by the distance of each item, which is 360 divided by the total number of items. It sounds a bit confusing, so let's try applying it to each specific item. As for the item in position 2, the result will be 90 degrees. Everything matches perfectly. So now, let's use this formula to write the code. According to this formula, a serious problem that needs to be solved is how to let CSS get information about the two variables, position and quantity. Many people will directly assign a specific number instead of quantity to CSS. As for position, they will mark it by creating class names like item 1, item 2, Item 3. However, this is not the correct way a programmer should do it. This method will make your code become hard-coded, and users will not be able to control the number of classes generated as well as the correct quantity value in other cases. Instead, CSS also has the ability to create variables and use them like in JavaScript. I create a variable quantity whose value is equal to the current number of items. Since this variable will be common to all items, I will place it in the slider. For each item, I create a position variable to mark the current position of each item. Each item will have a different position value. So, I got the two variables of the formula. Now, I will go through CSS to follow this formula. The rotation angle value in the y direction of each item will be calculated as follows. To perform math operations in CSS, we will use the calc function. To use variables, we must use the var function. Current position minus 1, then multiply by the average distance of each item. But I don't see any changes on the website. What is the reason? Let's look at this formula again. We can already calculate the required value. However, for rotate y to work, we need to provide units for that value, and the unit we need is degrees. To assign units here, we just need to multiply it by 1 degree. Multiplying by 1 does not change the original value, but it adds units to the original value, and this is the result. The next problem is how to create animations so that the items rotate in a circle along the y-axis. Some of you will think of solutions immediately, thanks to what we have done. That is, to create an animation for each item and change the rotate y value of each item continuously to create a circular rotation animation effect. This is not wrong, but it's not really good. Take a look at this example. This is quite a popular game. On top of this device will be many chairs. When playing, it will rotate. Let's say these chairs represent each item. As it rotates, the true nature is that these chairs remain stationary. They are already fixed on the device. But the thing that actually rotates here is the device frame, which holds all the chairs. So, if chairs are class items, this device frame is the class list which contains all items, right? So now, instead of creating an animation that changes the rotate value of each item, I will do it with the slider class. I will let the slider class run an animation called Auto Run for 20 seconds and repeat continuously. Inside this animation, I call the transform property again. The perspective value does not change. Change the y rotation direction from 0 degrees to 360 degrees to complete a circle, and it worked. If changing the y rotation direction will help the element move horizontally, then if I change the x direction of rotation, I will be able to see other angles of the slider vertically. This is crazy. So, we can complete the process of creating animation for the 3D image slider. Next, I will add content to complete this project. In HTML and Banner, I create an additional content element to contain the content, an H1 tag to write the title, and the author to record author information. Finally, I create one more element with the name model. This element will be used to display the model image. Now, let's go back to CSS. The content element will use position absolute to fix the position in the banner without affecting the slider, 0 away from the bottom. Combine left and transform to center the element. Fixed width is 1,400 pixels, but must not exceed 100% width of the device screen. Height max content. Padding bottom 100 pixels. Use display